Hi, I'm Miss Nickerson.
I'm Miss Radford.
Welcome to the Viking Science Academy. This is your last lecture on chemistry, and today we're going to talk about applying chemistry to different things. So let's talk about some chemical properties of things, and let's talk about acids. What can you tell me about acids?
Man, acids are they're
Acidic.
in a lot of they're in a lot of things that we eat, things that we kind of use to clean, those kinds of things. So they basically they dissociate water molecules. Basically, you get an acid on you, it's going to rip the water particles apart.
All right.
So.
Tasting them, they taste pretty sour, like grapefruits and lemons are very acidic, and they can corrode metals. And like you said, they react with salt and water pretty aggressively. And they produce a negative ion also when they are active. Bases kind of have the opposite. These guys produce an OH negative ion. They taste bitter and chalky, and kind of like old coffee is really base.
Toothpaste.
Toothpaste is good, or the stuff you put into your stomach, like Pepto-Bismol, is very base, and it helps calm the acid in your stomach. And it feels soapy and slippery. Well, if you want to find out how much of something is...
Ashley Holder to the main office, please. Ashley Holder.
Hurry up, Ashley.
Mike Whalen to the main office, please. Mike Whalen.
If you want to find how much of something is in something else, we call this solubility. We're going to be doing a lab on this in class. And so solute is the amount of the particle you'd add into it. And then you could take that as a fraction. So it's a percentage. So the amount of solute per water. And we would use, for example, 100 grams of water because that makes the math pretty easy.
So would water be the solvent?
That's correct. The water is the solvent, what we put the solute in. I don't know why scientists don't come up with better names. Sometimes they're really close. There's only a certain amount of solute that can go in a solvent, and I explained that it's kind of like iced tea. You can add sugar, but at a certain point, that sugar, it's just not going to dissolve, even if you stir and stir and stir.
It's one of my favorite summertime drinks.
That's called the saturation point. No more of that solute is going to dissolve in it. If it's got as much in it as it'll hold, we call it a saturated solution, and if it'll still hold a little bit more solute, we call it unsaturated. So go ahead and perform our learning check real quick. We tell you the saturation point, and you'll tell us if this is a saturated or unsaturated. Remember, it's just a easy division percentage problem. Now, one thing that does affect the solubility is temperature. I do know that if I heat that tea up, it's going to hold more sugar. And so that's true for most solids and liquids. If you heat them up, they can have a higher level of solubility.
They'll dissolve, they'll break down a lot better.
It increases. That additional friction and the additional energy with the heat can really make a big effect. Now, gas is a little bit different. As I heat up a gas, its solubility decreases. So the hotter a gas is, the less it will mix with other things.
They expand and they won't absorb.
They won't absorb. All right, so we got two questions here, one about a gas and one about a liquid, and see if you can tell us about how their solubility changes as the temperature changes.